Welcome to my channel. This is E. Manjula, lecturer in Electrical and Electronic Engineering, Government Institute of Electronics. So, in the last session, we have discussed about the RMS and average value mid-ordinate method. So, today we will see analytical method. Okay. So, the previous class we have discussed about the calculation of average and RMS value by using a mid-ordinate method. So today we are going to calculate the average and RMS value by analytical method, form factor and also peak factor we are going to discuss. Okay. So what is an average value? So see, when we are discussing about the average values by two methods, though we have discussed the definition before, yes, it is necessary to discuss to state the definition again and again, but yes, you have to remember the definition, so you have to write the definition like the same. Okay, so it is defined as the steady current which transfers across any circuit the same charge as transferred by an alternating quantity during the same time. So we know the definition already. So calculation of the average value by analytical method. So we will see how an analytical method, the calculation of average value will be done. So here the average value is equals to 1 by t integration 0 to capital T, that is a time period, f of t into dt. So capital T is the time period of an alternating quantity and f of t is a function of time. So here I is equals to Im sine theta. So this is an instantaneous value which is equals to I maximum sine theta. So I average is equals to 0 to pi to half cycle. Okay. So we know that. So this will be 0 and this is pi and this is 2 pi. Okay. So for half cycle we are calculating the average value. So 0 to pi by I of d theta divided by pi minus theta. So that is I maximum pi 0 to pi sine theta d theta. Okay. Here, so I is nothing but we have to substitute the I value. The I value is Im sine theta. So the same we have substituted here. So I maximum sine theta d theta. Okay. So here integration of sine theta is equals to cos theta. So cos theta, the limit supplied, that is 0 to pi. So the limit supplied 0 to pi. So here what happens? Cos of pi is plus 1, minus of minus cos of 0 is equals to minus pi minus 1. Okay. So minus of minus plus 1 and plus 1. So the value is 2 into I maximum by pi. Okay. So here plus 1 plus, minus of minus plus 1. So plus 1 is 2. So 2 pi maximum by pi. So the average value of so the average value is 2 I maximum by pi. So which is equals to 2 by pi. The value is 0.637 I maximum. So average value I average is equals to 0.637 I maximum. So I average is equals to 0.637 into maximum value. So we have calculated the I average value. We will discuss check about the root mean square value, that is the RMS value. Okay. So what is an RMS? The RMS value of an alternating quantity is given by that steady, that is DC current, which when flowing through a given circuit for a given line produces by the alternating current when flow up through the same circuit for same time. So the RMS value is equals to, so finding out the RMS value in an analytical method, that is RMS value is equals to under root of I by t, that is time period. So 0 to t f of theta square d theta dt. Okay, where capital T is the time period of an alternating quantity and f of t is a function value. So here the function is I. Okay, so I RMS is equals to under root of 0 to pi. So this is RMS value for this total waveform. Okay, so 0 to 2 pi I square d theta divided by 2 pi minus theta. So here what is I? I is nothing but I maximum sine theta. So I am, so here I am square, we are substituting in I place I am sine theta whole square. So I square sine square theta. So I am square sine square theta will come here. So this is 2 pi. Okay. So what is a sine square? Integration of sine square will become 1 minus cos 2 theta. So here now we are substituting. Okay. So sine square theta is equals to 1 by 2, 1 minus cos 2 theta. So 1 by 4 here. I maximum square 4 pi 0 2 pi into 1 minus cos 2 theta d theta. So we have to substitute 2 theta in this place. So here this is become theta minus sine of 2 theta divided by 2, 0 to 2 pi. Okay. I maximum square 4 pi theta minus sine 2 theta by 2, which is limits from 2 theta by 0. So here I maximum 4 pi square into 2 pi. So here 2 pi will get cancelled, 2 will be there. So I maximum by under root of 2 is equals to 0.707 I maximum. So this is the IRMS value. IRMS is equals to 0.707 into maximum value. So what is a form factor? The form factor is a ratio of RMS value to the average value of an alternating quantity. So form factor is equals to RMS value divided by average value, which is equals to 0.707 I maximum divided by 0.637 I maximum. I maximum, I maximum will get cancelled. So total form factor is equals to 1.11 value. There is no units for this because both the denominator and numerator are of same units. Okay. So peak factor. Peak factor is also called as crest factor and also called as amplitude factor. So here peak factor is a ratio of maximum value to the RMS value of an alternating quantity. So peak factor is equals to maximum value divided by RMS value, which is equals to I maximum divided by I maximum by root 2. So root 2 will go up. So I maximum will get cancelled. So root 2 value is 1.414. So peak factor value of a sinusoidal alternate of an alternating quantity, that is peak factor is equals to 1.414. So in this session we have discussed about analytical method of calculating RMS value and average value, form factor and peak factor. So we will go for the quiz points. The form factor of an alternating quantity is the ratio of RMS value to average value. The peak factor of an alternating quantity is the ratio of maximum to RMS value. So I hope this session is understood to you all. This is what we have seen is an analytical method. So till now we have gone through the mid-ordinate method and also analytical method of calculating RMS and average values. So the formulas need to be remembered so that in future problems we will use these formulas. So hope this session is understood to you all. So we will meet in the next session. Thank you so much.